All right, so today we're going to continue our look at the unit circle. So yesterday we zoomed in on this quadrant 1 and we filled in all this information about what's going on with quadrant 1. So the degrees, so 0, 30, 45, 60, and 90. Okay. Those exact same angles in radian measure. So again, 0. I do it this way. I know that this one is pi over 2. I then cut that in half, pi over 4. I know that 60 degrees is pi over 3. And then I cut that in half and get pi over 6. We also talked about these points that are on the unit circle. That this is the point over 1, up 0. If you do the y's, now I'm going to do the y's because those are the sign values, and those are the first ones that I think of when I do that chart that we just did. That it starts with 0, and then it goes up to 1 over 2, and then it's radical 2 over 2, and then it's radical 3 over 2. So those three, so you'll see the 1, the 2, and the 3. It's just these two have radicals on them. And then we're going to end, if we start with 0, we end at 1. And then the x-coordinates, those are the same as the cosine values. So that's going to, I'm going to start up here. I'm going to 0, and then I'm going to write the same numbers, but in the other opposite direction. So 1 over 2, radical 2 over 2, and radical 3 over 2, and then we're going to end at 1. So there you go. So that's what we did yesterday. What I want you to do is I want you to pause this video and see what you can fill out. It's how much of the rest of the circle you can fill out. My advice would be to start with the degrees, because that's what you're going to be the most used to, most familiar with. Think about what happens as you move around. Think in terms of reference angles. So, for example, if this is a 30-degree angle, then over here you've got this kind of mirror image. This angle is also 30 degrees away from, this is 180, right? So that's going to be 150. Think like that. Do the same thing for the radians. See if you can think of the radians. If this is 1/6 and this is pi, think about what being 1/6 less than pi would be. Or down here, this will be 1/6 past pi. So think about what those fractions are going to be. And then lastly, think about these ordered pairs. Again, think in terms of symmetry. Okay, here's your hint. That point, so think about how we move to get to this point. I know it's a weird movement. We go over radical 3 over 2, and then we go up a half. Think about what you would do to get to this point. That is a mirror image of this point, but we're going this way, and then we're going this way. Or this point down here, where you go left, and then you go down to land on that point. Think about how that's going to change the ordered pairs. So, now, pause the video, see what you can do, and then come back and I will fill it out as well. Alright, so that is what the filled out complete unit circle looks like. So those are all the angles in radians, and then also all the XY coordinates that are sitting on that circle that our angles pass through. Now, I'm going to let you in on something. When I fill this out, I usually jump around. So like, for example, I will do all the angles that are like have reference angles of 30. So I'll go 30, then I'll jump over here and go, okay, that's 150, that's 210. So I'm just doing the 30s in my head. And then I come over here and subtract 30 from 360 and I get 330. Especially with the radians. This is pi over 6. If this is 1/6 less than pi, it's 5 pi over 6. If this is 1/6 more than pi, it's going to be 7/6, because I'm thinking of pi as 6/6. So I'm just adding 1/6 to that, so I get 7/6. And then over here, I'm 1/6 away from a complete circle. So a complete circle is 12/6, and so it would be 11/6. So if you jump around, it helps you just keep that same denominator, that same common denominator, and you're not having to switch fractions, and you're just being consistent with those, okay? But more importantly is probably the points. What is going on with the points as you travel around the unit circle? You'll notice we had these points already. These points are all positive. But as soon as you move over here into quadrant 2, to get into quadrant 2, you have to go left and then up. So all your x coordinates should be negative, but your y coordinates should still be positive. That's going to be super important here in a second. Okay? Quadrant 3, you're going left and then you're going down to land on a point that's in quadrant 3. So both of those are negative movements. So you've got your x and your y coordinates are both negative if you're in quadrant 3. And if you're in quadrant 4, you've gone right and down. So you've gone in a positive direction, then you went in a negative direction, and that's how you got into quadrant 4. So your x's are positive and your y's are negative. Well, why is this important? Well, because now we're going to look at how do all these points relate to the sine, cosine, and tangent of the angles that were given. Okay? So, first off, let's look at 30 degrees. So look at 30, and what is the sine of 30? Well, the sine of 30, remember, sine is the y value of that ordered pair, and cosine is the x. So the sine of 30 is 1/2, 1 over 2. Now, I want you to look on the other side and look at a 150-degree angle that has a reference angle of 30. Remember, we talked about reference angles the other day. Well, what's the sine of 150? Again, it's the y value of the point that it goes through, which is also 1/2. What about 210, which also has a reference angle of 30? Well, its y value is negative 1/2, so it's got the same value, the 1/2 part. That ratio is the same, except it's negative in quadrant 3. And then when we move over here to quadrant 4, 330 degrees, still reference angle of 30, has the same ratio, 1 over 2, but again, it's negative. And you're going to notice that this is consistent throughout the circle. The sine, the cosine, and tangent values don't change. Okay? The sine of 45 degrees is radical 2 over 2. And the sine of an angle over here that has a reference angle of 45 is also radical 2 over 2. So those values aren't going to change. The only thing that changes is whether they're positive or negative. So if we can keep track of that simple, just is this fraction positive or is it negative, then I don't need to memorize all these things. I just need to know these, and then I need to know whether I should be making that fraction positive or negative. That ratio. Okay? So, in quadrant 1, the sines are positive, the cosines are positive, and since tangent is the y over the x, or the sines over the cosines, it's going to be positive as well, because you're taking a positive divided by a positive. So right up here it says positive and negative. So all of the trig functions are positive in quadrant 1. Everything's positive, okay? Including the reciprocals. That makes sense? Take a positive, flip it, still positive. All right, so what happens in quadrant 2? So in quadrant 2, the sines are positive. The y values are positive, so that means the sine is positive. The x's are negative, so that means the cosine values of these angles are negative. So the cosine of 150 is negative radical 3 over 2. Cosine of 135, negative. So the cosine is negative. And then what would the tangent be? Well, the tangent is the y divided by the cosine, or the y divided by the x, or I should have said the sine divided by the cosine, but I shouldn't mix them up. So this is a positive number, this is a negative number. If you take a positive divided by a negative, you're going to get a negative. So you're going to have that negative sign in your problem. So tangent is also negative. So sine is the only one that's positive. So what we're going to do is we're going to say, okay, if we can just remember where things are positive, then by process of elimination, the other ones are the ones that are negative. So in quadrant 2, sine is positive and only sine. Okay? What about in quadrant 3? What happens? Well, these are both negative. The y value, so the sine is negative. The cosine is also negative, but what about the tangent? If you're taking a negative and dividing it by a negative, those negatives are going to cancel. So in quadrant 3, the tangent is the positive one. The other two are negative, tangent's positive. So we're just going to have to try to remember that. All right. And then in quadrant 4. Quadrant 4, you've got positive x values, so that is the cosine. You've got a negative y value, so the sine is negative. And then the tangent, again, you're taking a negative, dividing it by a positive, so that is going to give you a negative, and so the tangent is also negative. So that's the cosine. So this is what we need to keep track of. They are all positive in quadrant 1. The sine is positive in quadrant 2. Then the tangent is the positive one, the only positive one. Now, its reciprocal is positive, but let's just worry about the three main ones, and then when we flip a fraction, we'll flip it. So the tangent is positive, and then the cosine is positive. So if we can keep track of that, then all we need to know is, what is the reference angle? So 150, like what is the cosine of 150? Well, 150 has a reference angle of 30. So it's going to have the exact same cosine value that a 30-degree angle is, which is on that chart that we made. We're going to do the chart when we turn the page. But then, since sine is positive in quadrant 2, our answer is going to be negative, because I'm asking you for the cosine of 150. So we're going to use our chart to come up with the radical 3 over 2 part, but then we're going to have to know that, oh, we're in quadrant 2, cosine is negative there, so we're going to make it negative. Okay? Okay, so again, this is what we're going to need to know. We're going to need to know this chart. Okay, so if you want to see if you can fill this in kind of on your own, I'm going to do it quietly as you do it. See if you can fill this in. If you get stuck, you can look up here. Okay, so that's the chart. If you are still not sure how to fill that in, you may want to watch as I do it and watch the order that I do it. Okay, a lot of times people want to fill in like columns. They want to do the columns, and I'm telling you, do the rows. Do the sine row. All it does is count up. So 0, and then it's 1 over 2, radical 2 over 2, radical 3 over 2, and then you're going to end at 1. And then once you have that, you're done. The cosine row is just that row written in the other order. And if you watch me, I did that. I went this, and then I came and did this. And then the tangent row, I'm just dividing these two. I'm doing that in my head. 0 over 1 is 0. This is 1 over radical 3, and then I just kind of rationalize that in my head. This is always going to be a 1 because these are going to cancel. So I'm doing that in my head. I'm just not saying it out loud. Okay, so that's our chart. If we can keep track of what happens as you move around as far as things being positive or negative, then we don't need to memorize all the angles. We just need to know these, which are the reference angles. Okay, so this isn't just a 30-degree angle. This is I'm talking about any angle that has a reference angle of 30 degrees. Okay, so here is our this is a little mini unit circle. And what you need to know, you need to remember where things are positive. So here's how I'm going to do it. I'm going to go around in a circle, quadrant 1, 2, 3, and 4. I'm going to go in that order, and I'm going to say this to myself. I'm going to say, all students take calculus. But here's what I'm going to write down. All students take calculus. All right, so what does that really mean? Those are the angles, or those are the trig ratios that are positive in those quadrants. In this quadrant, they're all positive. That's what the A stands for. All the trig functions are positive. As you move over here, sine is the positive. That's all we need to know. If you know sine is positive, then that means the other two, right by process of elimination, are negative. This is tangent. That's positive, so the other two are negative. And this is cosine. That's positive, so the other two are the negative ones. That's it. You just got to know where the trig functions are positive or negative based on the quadrant that you're in. Now, a little hint. What if you're not in a quadrant? What if you're like here or here? You're one of those like quadrantal angles. I'm going to tell you that you can use the chart, but it's probably actually easier just to look at these points, okay? Because these points are going to be points that we could easily, okay, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, if I'm over here, again, this is the, so let's remember, when you're looking at a point, it's the cosine and then the sine value. So if I say to you, like, what's the cosine of 180 degrees? Okay, now you can come over here and you can say, okay, cosine of 180 would have a reference angle of 0. But so you're going to get an answer of 1, but it's not 1, okay? Because we're over here. We're on the other side of the circle. Cosine's positive over here. In both of these, it's negative over here as well. If it's negative in these two quadrants, it's also going to be negative on that boundary line between them. But if you just look at the point negative 1, 0, you're going to see that negative sign, and then you're going to know it's negative, and you're not going to worry about it, okay? So for those quadrantal, when you're not in a quadrant, you may just want to look at these points and see if that helps you determine whether things are positive or negative, okay? So look at the first example. What is the sine of 135? I don't know. I'm not going to worry about that. What I'm going to do is I'm going to ask myself two things. What is the reference angle of 135? The reference angle is 45. And also, where is that angle? Not the reference angle. Reference angles would always be technically in quadrant 1 because they're always acute. 135 degrees is in quadrant 2. Okay? Those two pieces of information, that's how I'm going to determine the sine of 135. I'm going to use my chart to figure out the ratio. Sine of 45 is radical 2 over 2. And I'm going to use the quadrant to determine whether I leave it as is or whether I should make it negative. Well, sine is positive in quadrant 2, so we're done. That's your answer. What is the cosine of a 240 degree angle? All right, so 240, now we're over here in quadrant 3 because we've gone past 180. How far past 180? Well, 60. That's our reference angle. And again, these two pieces of information, that's all I need. Cosine, so what I'm really going to do is I'm going to do the cosine of 60. Cosine of 60 is 1/2. But cosine is negative in quadrant 3. Tangent's the positive one, so cosine has to be negative, so it's actually negative 1 over 2. And if you flip your notes and you take a look at the actual unit circle and you find 60 degrees, or you find, what was it, 240? Okay, so 240, and if you want to know the cosine, it's negative 1/2. But I don't want you to have to memorize this entire circle. Just use the chart and determine whether things are positive or negative. That's it. Okay? Tangent of 330. So where is 330? What quadrant? It's going to be in quadrant 4. So already I'm thinking that's going to be negative. Okay, I know that cosine is the one that's positive in quadrant 4. This one's going to be negative. Negative what? Okay, so I need a reference angle. Reference angle of 330. I am 30 degrees away from being a complete circle. So I'm going to go tangent 30. It's radical 3 over 3, but I'm going to make it negative. Negative radical 3 over 3. That's it. That's all we're doing. Okay, what's the sine of pi? Pi is not in a quadrant. Okay, it's right here. So for this one, I'm just going to say, oh, the sine of pi, well, that's the y value of that point, which is just 0, so it's 0, and I'm done. Okay? All right. How about number 5? What is the secant of 5 pi over 6? Ooh, there's a little bit going on here. 5 pi over 6 is in quadrant 2. Okay, we're not quite to 1. We're over here, 5, 6. The reference angle is pi over 6. because we are 1/6 away from 1, so pi over 6. But this is asking us for the secant. I don't know that, okay? Secant isn't on our chart. That is the reciprocal of cosine. So here's what I'm really going to do. I'm going to do the cosine. I'm going to do 1 over the cosine of 5 pi over 6. But I'm going to use this information right here. Okay, so reference angle is pi over 6. So I'm going to find the cosine of pi over 6. Cosine pi over 6 is radical 3 over 2. This angle is in quadrant 2, so it should be negative, because cosine is negative in quadrant 2. So it's going to be, so the cosine would be negative radical 3 over 2. One more thing, I got to flip it. Okay, so this is technically, this is like 1 over the negative radical 3 over 2. This is just a fancy way of saying the reciprocal of something. So now we're going to flip it. We're going to take the radical 3 over 2. We're going to rewrite it as 2 over radical 3. If you want, you can go ahead and rationalize that. If you're good at that, you can kind of do that in your head. So when I flip it, I get 2 over radical 3. So that is going to be 2 radical 3 over 3. But it was negative, so this is negative. That is my answer. And that is as hard as it can get. Okay, I've done everything. I put it into a quadrant. I gave you an angle that you had to use a reference angle for. Okay, I gave you a quadrant, an angle that was in a quadrant where that value was negative, so we had to keep track of that. And then we had to take the answer and we had to flip it. That's it. Okay, so take a look at number 6. What is the cotangent of 4 pi over 3? You're going to do the same thing. You need to know where that angle is. 4/3. You've gone past 1, so you're in quadrant 3. How much into quadrant 3 have you gone? Well, you've gone 1/3 past 1. So our reference angle is pi over 3. And since this is cotangent, what we're actually going to find is the tangent. And then we're going to do the reciprocal of that. We're going to do the reciprocal of tangent. So this is what we're going to do. We are going to find the tangent of pi over 3, which is radical 3. The tangent of radical 3, or the tangent of this angle, since it's in quadrant 3, should be positive. So it's going to be positive radical 3. But now we have to do the reciprocal of it. So I'm going to take the radical 3, I'm going to flip it, which is going to make 1 over radical 3. But then so this is equal to 1 over radical 3. But then I have to rationalize that. I need to move the radical up, write the 3, and again, this one should be positive, so we're not going to put a negative sign in front of it, and that is our answer. Okay? How about 7? Where is 7 going to be? Negative 270. All right, so we're going this way. So negative 270 is up here. Okay, that's like same as a 90-degree angle. In fact, that's your reference angle. Okay, just use that. So the reference angle is 90. Secant is the reciprocal of cosine. Okay, so here's what we're going to do. We're going to do the reciprocal of the cosine. We're going to find the cosine of 90. Well, that's 0, right? It's the x value. But then we have to do the reciprocal of that. So if I take 0 and flip it, in other words, I'm moving the 0 to the denominator, that's no good. That's undefined. The secant of that angle is undefined. There is no secant value because we're trying to divide by 0 and you can't do that. Okay? Last one, sine of negative pi over 4. So think about where that is. Where is negative pi over 4? Well, we're rotating this way, so we're here in quadrant 4. So this is an angle in quadrant 4. It has a reference angle. Well, if we've rotated negative pi over 4, that means we are pi over 4 away from the x-axis, so that's our reference angle. And since sine is negative in quadrant 4, we're going to make it negative. So sine pi over 4 is radical 2 over 2, but it should be negative radical 2 over 2. That's it. Okay? All right, so what if I'm going to add one step, okay? So what if I gave you an angle that's like too big, Okay, so like what is the sine of 330? Or what is the tangent of 19 pi over 4? That's way more than one revolution. Well, we're going to do what we did before. We're going to unwind them. Okay, we're going to turn this, so this will be two-step. We're going to first turn this into a coterminal angle that we can better understand. So 390, we're going to subtract 360, that's going to be 30. There. I'm not doing this anymore. I'm not trying to find the sine of 390. A 30-degree angle is exactly the same as a 390-degree angle, so this is what I'm going to do. I'm just going to find the sine of 30. Well, that's in quadrant 1. It is its own reference angle, so I'm just going to go straight to the chart. I'm going to see the sine of 30 is 1/2, and we are done. Okay, that's it. So 19 pi over 4. Well, those are in radians, so we're going to have to unwind it. So we're going to subtract 2 pi. So think about what 2 is going to look like. I have a denominator of 4, so it's going to be 8/4. So that's what I'm going to subtract. 8 pi over 4. Well, 19 minus 8 would be 11. So I'm still too big. Okay. And then, I'm trying to figure out where to write this. So 11 pi over 4. If I subtract another rotation, 11 minus 8 is 3. So 3 pi over 4. Okay. That one I can do. Okay. I can visualize that. 3 pi over 4. That is in quadrant 2. Which means this angle was in quadrant 2. I just didn't know that. Okay, 3 pi over 4. It's in quadrant 2. And it has a reference angle of pi over 4. So that's what I'm going to do. I'm going to find the tangent of 3 pi over 4, which is, well, if it's in quadrant 2, it's going to be negative, because tangent is negative. Sine's the positive one, so tangent's negative. And then I'm just going to go to my chart. Pi over 4 looks like it's 1. That's it. Negative 1. Okay? See if you can do C on your own. Alright, so I wrote down everything I did, but I subtracted 2 pi, then I had to do it again, then I had to do it again, so eventually I got pi. So the coterminal angle for 7 pi is just 1 pi. So that's what I'm actually going to find. I'm going to find the cosine of pi. Now, that has a reference angle of 0. Because if you are on the x-axis, you are 0 away from the x-axis. So I could use my chart, but then I got to make sure I don't make a mistake. Remember, pi is on the negative x-axis right here. Here's 180 degrees. There's pi. So cosine is actually going to be negative 1. So that's what I would do. Cosine of pi is negative 1, and then you're all done. Okay? Now the bottom, last thing we're going to do, find the exact value of all 6 trig functions. So we're not just going to find the sine of an angle, we're going to find all of them. Well, this is not going to be 6 times as much work. It's going to be the same thing. 5 pi over 6. I need to know where this angle is. It's going to be in quadrant 2. And I need to know what its reference angle is. Well, that's going to be pi over 6. And now I'm just going to write down everything. I'm going to write down the sine, the cosine, and the tangent. Now, before I do that, because this angle's in quadrant 2, I know the sine is going to be positive, but the cosine and tangent are both going to be negative. So maybe you write those negative signs now so you don't forget them. And now we're going to go up to our chart, pi over 6. And we're just going to write down the whole column. Okay, so 1/2, radical 3 over 2, and radical 3 over 3. That's the sine, the cosine, and the tangent of that angle. And now I need the cosecant, the secant, and the cotangent of that angle, which is just going to be the reciprocals of these. So instead of 1 over 2, it's going to be 2. Negative. So this is going to be negative as well. And then it's going to be 2 over radical 3, which is 2 radical 3 over 3. And then the last one. Now this one's a little tricky. It's radical 3 over 3, and then we're supposed to flip it. So we're going to get 3 over radical 3. Well, stop and think for a second. Radical 3 over 3 has already been rationalized. Okay, on our chart, what we actually came up with was 1 being divided by radical 3, and then we had to rationalize that. So Think of what would happen if we flipped this. Well, if we took the original problem before we rationalized it and we flip it, it's going to be negative. Okay, that won't ever change. But if we flip that, we're just going to get radical 3 over 1, which is already rationalized for us. So we don't have to do anything to that one. Okay? Same with B. Look at B. 240. Where is it? Okay, what quadrant? It's in quadrant 3. By how much? How much have we gone into quadrant 3? Well, we've gone 60 degrees past 180, so that's our reference angle, 60. So, if we're in quadrant 3, tangent is going to be positive. The other two are going to be negative. And we're just going to write down all the ratios that we see under the 60-degree angle. So sine, cosine, tangent. If I write down the angles, it's going to be radical 3 over 2. It's going to be 1 over 2. It's going to be just radical 3, or radical 3 over 1, if you want. And then remember, these two are going to be negative, and that one's positive. That's it. The sine of 240 is negative radical 3 over 2. The cosine is negative 1/2, and the tangent is radical 3. Then we're going to do the cosecant, the secant, and the cotangent. And we're going to do the reciprocals of these. So again, it's going to be negative. The reciprocal of this is 2 over radical 3, which is 2 radical 3 over 3. Now move on to the next one. Negative. This is negative. Reciprocal of 1 over 2 is 2. And then this is positive, so this is positive. And this one, so when you flip it, it's going to be 1 over radical 3, which is radical 3 over 3. Okay? What are the 6 trig functions of the last one? Well, I need you to notice that that angle's too big. Okay? 8/3 is bigger than 2. Okay? So let's unwind it. Let's subtract 6 pi over 3. We're going to subtract a revolution, and we're going to get 2 pi over 3. Okay, we can deal with that. 2 pi over 3, so think about where that is, 2/3. That's in quadrant 2. And it has a reference angle of just plain pi over 3. So, quadrant 2, that's the quadrant where sine is positive, the other two are negative. So sine, cosine, tangent of this 2 pi over 3. Go look at my chart. The sine is going to be radical 3 over 2. Cosine is going to be 1 over 2, but it's going to be negative. And the tangent is going to be radical 3, but it's also going to be negative. Okay? And now you just need to take those 3 and you need to flip them to find the cosecant, the secant, and the cotangent of the angle 8 pi over 3. So what's this? 2 over radical 3, so 2 radical 3 over 3. Negative 2. And then negative 1 over radical 3, which again is radical 3 over 3. So you're going to see these same values a lot. Okay, so you're going to get familiar with what they look like when they're rationalized, that if you take a radical 3 over 2 and flip it, you're going to get a 2 radical 3 over 3. Okay, it's happened quite a few times on here because these numbers are going to repeat themselves a lot because we're just using the values from that chart. Okay, so take a look at your homework. Keep these notes out, match them up. Okay, if I ask you to find, the exact values using coterminal angles, you use this as a guide. Subtract 360, subtract 2 pi, turn them into coterminal angles before you try to use your chart and reference angles and things like that. Okay, so take a look at your worksheet, and if you have questions, let me know.